Now, after understanding the relationship between zeros and coefficients of polynomial, now we have this exercise 2.2. The question is find the zeros of the of the following quadratic polynomials and verify the relationship between zeros and coefficients. So this question is in two parts. First, you have to find the zeros of the polynomial. So let first questions first part I have taken x square minus 2x minus 8. So this you can see the factorization by middle term split you can do. 4 is this is minus 4x plus 2x plus 8. So now this is minus 8, so take x common, so this will be x minus 4. From here you take 2 common, then x minus 4, so this is x minus 4 and x plus 2. So therefore zeros are x equal to 4 and x equal to minus 2. See, we can also say that also we can say alpha equal to 4 and beta equals to minus 2. So sum, now the first part we have done, that we have found zeros. Now the next part is that we have to verify the relationship, and relationship is that sum of zeros equal to minus b by a. So we'll do LHS, sum of zeros. So zeros are alpha and beta, so you can write alpha plus beta. So this is this alpha is 4 and plus minus 2, so this is 2. So we take RHS. Now RHS is this minus b upon a. The value of b, from here we can see the value a equals to 1, b is minus 2 and c is minus 8. This is minus 8. So we can use these values here, that b is minus 2 and a is 1, so this is 2. Therefore LHS is equal to RHS. So we have verified our first relation, which is about sum of zeros equal to minus b by a. Now the next is your product of zeros is equal to c by a. So we'll take LHS. LHS is product of zeros. So product of zeros means alpha into beta, because these are the zeros. So this is 4 minus 2, answer is minus 8. Then c by a. C by a means your RHS. This is c by a. So value of c is minus 8. So minus 8 and a is 1. So ultimately it is minus 8. So therefore LHS is again now equal to RHS. So we have found the relationship verified, and it can be done in this question also. Here you see this is can be simplified as 4s square plus 1. This is actually 2s minus 1 whole square. So it can be written as 2s minus 1, 2s minus 1. So s is equal to 1 by 2 is and the second one is also s equal to 1 by 2 are the zeros. So again you can verify these two relations in this part also. Now I am coming to fourth part of this question, which is 4u square plus 8u. So let this be px. This is a polynomial, so let it be px. So now we'll simplify this. You can see the common is 4u. 4u is common, so u plus 2. So you have now two factors, 4u and u plus 2. So zeros are, put this factor equal to 0. So 4u equal to 0, you put, you will get u equal to 0, or you also put u plus 2 equal to 0. So you will get u equal to minus 2. Therefore zeros are 0 and minus 2. So these are the zeros. Now we'll verify the relationship. Sum of zeros equal to minus b by a. So we'll take LHS. LHS is sum of zeros, means 0 and minus 2. So this will be minus 2. And now RHS, which is minus b by a. So you see here in this question, a value is 4, b is 8 and c is 0. So now this is b is minus 8 upon a is 4. So answer is minus 2. So you can see LHS is equal to RHS. Now we have the second relation also to be verified, which is product of zeros equal to c by a. So I'll take LHS first. Product of zeros means 0 into minus 2, which is 0. RHS, which is c by a. C is 0, a is 4. So ultimately this is also 0. So therefore LHS is equal to RHS. So second relationship is also verified. Now this this is the fifth part, and I want that you try yourself, but little help I'm just giving you, that you can write this as t square minus root 15 whole square. Then this can be written as t minus root 15 t plus root 15. So zeros are, this factor will become 0 when you put t equal to root 15, and second one is t equal to minus root 15. Now you verify the relationship yourself. I have done in 2 examples. Now come to question number 2, exercise 2.3. Question is that find exercise 2. This is 2.2. Find quadratic polynomial in each with given numbers as the sum and product of its zeros. See here I have used another color pen to you highlight the thing that the first number, which is here in first part, you see this is 1 by 4. These are not the zero, this is the sum of the zeros, and minus 1 is the product of the zeros, and you have to find the quadratic polynomial. So I am giving you the formula to find the quadratic of the polynomial. So the formula is that px k, this is x square, and this s x, and this is p. Here s stands for sum of zeros and p stands for product of zeros. So now in first part, this value is given to you as 1 by 4, and this value is given to you as minus 1. So your answer will be, px will be k, where k is some constant, where k is some constant. So this k is now x square minus s is 1 by 4 x, and p is minus 1, so plus minus 1 this. So this is your answer. And this is also very important to tell you one thing, that there are actually infinite number of polynomials, or say you can say quadratic polynomials, because this k value keep changing. You can say k is 1, sometimes k2, k3. So there is no fixed value which k can take at a moment. So according to this formula, there are always infinite number of polynomials which can have 1 by 4 as sum of zeros and minus 1 as product of zeros. So k is very important, has to be mentioned always. Now part 2, you see this now this s is given root 2 and this p is given 1 upon 3. So you can write equation the polynomial px as k x square, this is the formula as x plus p. So this is now k is will remain k as it is, x square, s is root 2, so this is root 2x, and p is 1 by 3, so this is 1 by 3. If you want to simplify this, it's okay, otherwise you can leave up to this only. In simplification you can take LCM common, and then this 3 will come out, it will be k by 3, 3x square minus 3 root 2x plus 1. So it is okay if you leave this polynomial in this form only. Now this is your fourth part, that s is 1 and p is also 1. So apply the formula px equal to k x square minus sx plus p. So k x square, this will be x plus 1. So this is your answer for part number 4. And now I want that you should also think of this, how to write the polynomial. So for the time being, I'm just writing the answer directly. X square plus 1 by 4 x plus 1 by 4. And you can see how I have done this. You can apply this formula and you can come to this answer. So this answer should be matched. Now we are going to discuss division algorithm for polynomials. This is you have seen this in terms of numbers in Euclid's division lemma. The same thing is now coming here also for polynomials, and we say this division algorithm for polynomials. If px and gx are any two polynomials, it can be of any degree, with gx not equals to 0, but gx should not be equals to 0, then we can find polynomials qx and rx such that px will be equal to gx into qx plus rx. You can see the degree of px is greater than degree of gx. Euclid division lemma, you have seen that a greater than b. Here now we will not say a greater than b, we will say degree of px greater than degree of gx. And in Euclid division lemma we say that remainder can be equal to 0 or less than b. B was your divisor. Here degree of rx greater than equals to 0 but less than equals to degree of gx, which is the divisor. So we have used this now, but we are going to do this in questions. Long division you have done in class 9th also. So now this long division is coming again in class 10th, and 4 marks, question having 4 marks is normally asked in the exams from this chapter basis on the long division. So that px is this and gx is this, you have to find the quotient and remainder. So we'll go with normal division, that x square minus 2, this is x cube minus 3x square plus 5x minus 3. So this I have written in the division form. You must remember one thing which is very very important, and I'll ask maybe later on from you all, that px, this dividend and this divisor should be in the general form. General form means the highest variables should be, power of the highest variable should be first, then lower, then at last the lowest one. Similarly here also the highest power is x square minus x square, and then lower power is x0, which is 2 is the coefficient of x to the power 0. So both dividend and divisor have to be in general form, means the power should be higher in the first term, then lower, this way. You cannot divide minus 2, you cannot say minus 2 plus x square, then this division will be wrong. So you know that how we go about it. So if you want, I can little bit I can do for you, that first you take the first term of the dividend and first term of the divisor. So this will be your x. So x will become the first term of your quotient. Then this x has to be multiplied with this gx, means this x has to be multiplied by x square minus 2. So your answer will be x cube minus 2x. So that has to be written down this dividend, x cube minus 2x. Now you change the sign, this is minus and then this is plus. So first term must always get cancelled. So this is minus 3x square and this is plus 2x, but you have to write the remainder also in the general form. So minus 3x square has to be written first, and then 5x, and this is plus 2x. So 5x plus 2x, it is 7x minus 3. You must all remember that the like terms are to be subtracted or added. So 3x square, this 2x is they are not like terms, so will not, we cannot add, we cannot subtract. So I have just taken this as it is, and I have added these two like terms. So now next step is take the first term of your, because now this is going to be your dividend 3x square, and your first term of your divisor, which is x square. So this becomes minus 3, and this minus 3 will be your second term of the quotient. So minus 3 is to be multiplied by x square minus 2, so it is minus 3x square plus 6. So you write this minus 3x square plus 6. So 6 should be written here down this number 3, because these are like terms. So this is plus, this is minus, this got cancelled, this is 7x, and this is minus 9. Now you cannot go after this, because this degree has already come below the degree of divisor, which is x square minus 2. The degree of this x square minus 2 is 2, and the degree of this 7x minus 9 is 1. So whenever you get degree less than the degree of divisor, you stop. So now you can see the quotient is x minus 3 and remainder is 7x minus 9. So this is, we have found remainder and quotient. Now come to third part of this question, which is the px is given x4 minus 5x plus 6, and gx is given 2 minus x square. So you can see that very important thing, that gx is not in the standard form, because x square, which is the highest degree term, should be at first. So you will have to write this x square, and this is 2, you have to write it last. Now you do the normal division, x4 minus 5x plus 6 divided by minus x square plus 2. So we'll go ahead now, as I've done here also, I'll do this again here also for you. You take the first term of the dividend and take the first term of your divisor. So you will get minus x square. So that minus x square has to be multiplied by the divisor. So you will get minus minus plus x4 minus 2x square. So write this x4 minus 2x square. So you can see this is 5x. So we are not having this x square term, so we'll write that x square 2x square at last. Now change the sign, this is minus, this is plus. First term is got cancelled, so this highest term, then this is the lowest. So write that 2x square first minus 5x plus 6. Now again you go with first term of the dividend and first term of the divisor. So now you are getting, this is minus 2. Minus 2 should be multiplied by the divisor. So this is 2x square minus 4. So write that here we'll write first it was minus x square, and now this time this is minus 2. So this becomes 2x square minus 4. So this is minus, this is plus. Now this got cancelled. This is minus 5x and this is plus 10. Now you have to stop it here, because the degree of this remainder is 1 and degree of this quotient, this divisor is 2. So now the degree of remainder is less than the degree of divisor. So it means that remainder will be this only. And you may ask this, if you go after the division, then what will happen? In that case, if you go ahead, then this quotient will become an expression, because the next third term will be will have x as some negative number, x power as some negative numbers. So according to the definition of polynomial, so quotient this quotient will not remain the polynomial. So we have to stop it here only. So your quotient is minus x square minus 2, and your remainder is minus 5x plus 10. Now you will try question number 2 yourself. I'll be doing question number 3 and onwards, and will also do the option exercise. But your homework is that you do question number 2 yourself.